Hello and welcome everybody. We're gonna take like approximately 1 minute time until everybody can actually join the stream. And then we are going to start in about like, let's give it 30 seconds approximately. And we're very, very thrilled to have you here. Okay, good. We see that people are joining, so I would assume that we can actually start. A warm welcome from our side. Welcome to this YouTube Live. Elevate your craft, Autodesk Fusion and JoinerCAD for furniture design. My name is Nick Lieven. I'm the Industry Strategy Manager for consumer products, including also furniture at Autodesk. Alongside me, I got today Jonathan Gaffin, Sales and Product Strategy Manager at Autodesk, and Grashidas, who's the product architect at Shady APS, the company behind JoinerCAD. What we are talking about today is basically divided into three different blocks. I'm going to start and hit us off with a little bit about what is actually happening in the furniture industry. How can we see that we can actually help also companies in the furniture industry end to end with Autodesk Fusion? This is handled by Jonathan afterwards. And then we're going to dive deeper into how JoinerCAD can solve real woodworking challenges in the furniture industry. So, just to hit us off, I want to talk a little bit about what is actually happening in the furniture industry. What do we see from an outside perspective? And the first thing that we start to see is that the demand itself is shifting. Consumers are getting more and more actually impatient with receiving their goods. Moreover, people are saying, or at least 80% of people are saying, if the goods are not delivered within 4 to 7 days, sorry, they are actually very, very unlikely to actually purchase something. If you're going to put this into the contrast that supply chains are continuously being disrupted, especially if 60% of the furniture imports in the US are still coming from China and from Vietnam. This is basically a clash. This is something where companies are constantly telling us they are struggling with that. On the other hand side, products are changing as well. Consumers are telling us that, especially 9.7%, consumers are telling us that they are 9.7% more likely to actually purchase goods if they are with a sustainability record. That means the more sustainable a product are, the higher the likelihood it is actually that consumers are purchasing it. But in the future, that means also we need to know exactly what does sustainability mean for a product. In the future, there will be 100% of product data trackable with the upcoming digital product passport in the EU. And the third big trend pillar that we actually can see is that operations are continuously digitalizing their processes, especially also towards the consumers. 60% of people are mentioning that they have a higher likelihood to purchase goods if they actually see them in their real space. That means the usage of AR becomes really, really important for furniture manufacturers. If we're combining this now with this massive industry that the furniture design and manufacturing actually is, which is approximately 730 billion US dollars only in 2025, this is an approximate number, we know there's going to be a lot of different effects on the industry. And furniture manufacturers are basically telling us that they're trying to achieve three different things. They want to bring new products to the market. So, for example, what are the latest color trends? What are the latest interior design trends? They want to adapt their products to that. But with also e-commerce being even more important these days, as you have seen before, consumers are buying more and more online. New competitors are entering the market and challenging existing companies every single day. Also, in addition to that, new business models are actually emerging. We talked already about the direct to consumer business relationship. You as a brand can directly market, but also sell to consumers at the same time. So, what are you guys often really struggling with? And the first thing is you want to bring, of course, the more desirable products to the market. In the best of worlds, you're bringing them faster than your competitors to market. And obviously, you want to be, if possible, the most profitable organizations. But the interesting bits and pieces, even though these are like very human kind of things that you want to actually achieve, to do everything at the same time is extremely complicated. Businesses are telling us that they are often going down only one of those roads. Either they're choosing to develop higher desirable products, or they're actually going down the time to market route, or they are going into profitability. But they actively chose one of those three tracks. And next up, Jonathan is actually going to guide us a little bit through what does that mean for businesses and why are they struggling with achieving those things that they so urgently desire. Jonathan, are you there?
I am here, and I hope that you can hear me as well.
Yes, we do.
Fantastic. Now we're next to each other on the stage, and next to me, this chaotic slide that maybe will seem a little bit familiar to the one or other watching here, because what we see, and also us coming from the industry, we've noticed that different organizations within the same company or across different companies, they often have, of course, their own challenges that they're dealing with, but some of the biggest challenges come from having to deal with others. Tell me about it. The thing is that when we exchange data and we exchange information, oftentimes we have our proprietary information and also file formats often that we need to exchange. So there are things like neutral file formats that allow us to share data that everyone can understand, but in that we often lose important information as to who dealt with this, who created it, which versions did it go through, etc. So while collaboration between different organizations and even different companies and locations is crucial, oftentimes the systems that are required to do that don't allow for that. So what we do on our side, and I would ask Nick if you could advance to the next slide, perfect, is we approach this from a platform perspective. I know platform is a big trendy word, but really Fusion and Autodesk in the background, we've been building this for many years. In fact, Fusion has been around for over 10 years already, believe it or not. And Fusion, formerly Fusion 360, has been at the core of offering up CAD, and then also CAM, and then also, of course, simulation, etc. But that only covers one part of these organizations that we saw previously on that slide. There are processes that are required to be fulfilled, which can't necessarily be done by just a CAD tool. So things like mass customization or digital collaboration. How do you flexibly manufacture? How do you ensure a great customer experience? How do you offer smart services? All of this requires an end-to-end platform. And this is where Fusion, the Fusion platform, comes into play. Today, of course, we are speaking about particularly CAD and CAM, but that is one of the parts. Let's move to the next slide. Exactly. As I mentioned already, Fusion is not only CAD, and it's also not only CAM. It's also not only simulation or only drawings. It's in fact one product development platform that offers all of these different workflows inside of one tool. And they are connected seamlessly with a connected data management and also lifecycle management capability. So this is really a fantastic place to kickstart your product development process. let's move here to the next one again. Speaking about the product development process, of course, there are many different people involved in bringing products to life, from designing the first sketches even and bringing them into a 3D tool. This is where I come from. For example, I'm an industrial designer by trade. I used to actually co-own a furniture company, so this is very much where I feel comfortable. And then having to pass on that information over to engineering to suss out how will it actually work, will it be able to be manufacturable, will it hold up to the stresses of the real world environment, moving on to production engineering, making sure that something can actually be manufactured, are the right tools available, do I have to potentially redesign parts or assemblies so they can be made properly, and then moving on actually to the production itself, to the shop floor, to passing on parts in a format that a machinist will understand and be able to program CNC codes off of, so you can actually digitally manufacture your products. All right, let's go to the next one here again. Now, there are tons of companies that are using Fusion already. I encourage you to look through our customer success story showcase, but one of the ones that I wanted to highlight is our customer Ganas Manufacturing, who work in this furniture space. And they said previously we were using a different program for nesting to make the cut lists, but that's still susceptible to human error. Fusion has eliminated those kinds of errors. Now we know it's 100% correct, and that's a game changer. And you can tell by the image here on the bottom that you can see the kind of size and scale of furniture that they manufacture with hundreds of different parts. You really need to be able to trust 100% that the tool you're working with is providing the data that you need for proper production. Okay, let's move to the next one, because with that, I would like to showcase how Fusion actually works. So I'm going to do a little bit of a high-level showcase of Fusion, not going into too much detail, of course, because we want to speak to our JoinerCAD friends. You can see in the background as well, I've got all of my sort of workshop material as well, because I'm an avid worker and building furniture for my home as well. Let's see. I will share my screen, and you should be able to see Fusion now, hopefully. And I just wanted to show a little bit of a furniture design that I have inside of here, inside of Fusion, of a sideboard and this sort of armchair, and as well some surrounding bodies as well. Now, Fusion is, as I mentioned before, not only a design tool, but it is a very capable design tool. It comes with a bunch of different types of geometry that you can deal with. Of course, solid models being some of the most important ones to be able to design actual solid furniture in this case. You can, of course, also work with surfaces. So, for example, you can see this sort of funky looking 3D contoured drawer front or sort of slide front is made using the surfacing tool. And that is something that then a 3-axis CNC machine could very well cut out and create a distinctive, well-designed piece of furniture. You can also work with meshes, of course, if you're going into 3D printing. That's something that I see a lot of furniture designers use more and more in collaboration with conventional materials like wood and other wood materials. You can also work with sheet metal. I will say sheet metal is not exclusive only to metal. I've seen many customers use this workspace also for plastic sheets, for example, in sign making. This is also something that can happen in the furniture industry, plastic specific, and many more tools. You've seen here, I actually have a sort of working model where I can take these drawers out. I can move things around to make sure that things are actually working the way I want them to be. And here I have some other models brought into my design model, so I can move into other areas of design. Like, for example, I could go into rendering. because anything that I add to my piece of furniture will make it look a bit more realistic. So inside of here, I've got some views set up. So for example, if I want to see a view of the chamfer or of the start or any kind of views that I have previously set up, I can switch between them and then choose from a variety of different appearances and environments to make things look realistic. Here I've got a couple of renderings already prepared, so you can see this is sort of out-of-the-box rendering quality without me setting up too much on sort of lighting and so on. In my opinion, this is fantastic. You can really work with this. You can create convincing images to put on websites and brochures, etc., to convince your customers or your internal teams, of course. There are other workspaces like the animation environment as well, where, as the name suggests, you can create animations or things like exploded views, of which you can then also create drawings. You can publish these into drawings or into videos. You've got the simulation workspace where you can run finite element analysis in different forms. So there are various different study types that you can run, starting from static stress all the way to injection molding simulation, and then get results on how your models and your assemblies will actually perform. This is cloud-based technology, which is fantastic because you don't need a supercomputer to run Fusion. You can simply work on your laptop and let the cloud do the heavy lifting, which I've always appreciated, being on the go and being able to do even advanced simulation tasks. Manufacturing, of course, is a big area for Fusion as well. Here I have set up already one thing that our customer Ganas had mentioned, the nesting capability. This is something that comes up a lot, of course, in furniture manufacturing. So inside of the fabrication tab, you can set up all of the different components, the component grain direction as well, to make sure that components are laid out according to the grain and ensure good static stability, but also visual consistency. And then you are able to create nests with various stack sizes if you want, and include which shapes you'd like. You can set up your material library so you're working off of the right sheet sizes. And then what you'll get is an output of these nested sheets, which you can then use to automatically create setups from this manufacturing model. So this is something that I've already done here. I have a couple of toolpaths which allow you to see sort of how is this going to be manufactured with the tools that you have available, and then make sure that there are no collisions. And then once you have all of this done, you can go and post-process this machine code to your CNC machines. There are tons of free post-processors available as part of the Fusion license. So you can go straight from design to your CNC machine, which is, again, like I mentioned before, only possible because Fusion works on this integrated platform. There are other areas like electronics, which I won't get into today, and that's, for me, is a little bit of a dark art as well. But drawings, of course, you can create drawings from designs and animations. I set off a drawing earlier, which I didn't spend any time on. I just literally used the AI drawing creation. So this is automatic drawing creation, where it automatically creates drawings as well as dimensions. So here, this is an automatic task that Fusion can perform on any of your parts. So it takes a lot of the brunt work out of what you need to do in order to create dimensioning. It'll do it all for you automatically. However, there are, of course, things that Fusion is lacking as well. And this is where I'd like to slowly hand over to our partners today, JoinerCAD. Just before I do that, I want to mention there are some extensions to Fusion which extend Fusion's capability, but then there are, of course, also a lot of add-ins. And this is where you would get access to this, where you would get JoinerCAD capability by going to the Fusion App Store, over here. Let's see if this works. I'll actually move this over and take this one. So this is the Fusion App Store, and then you can just simply look for JoinerCAD, and here you'll see the add-in that you can then install. And you might have noticed I'm working on a Mac. I find it fantastic that it's also available for Mac OS, but as well, of course, for Windows. So here you can download it, and with that, that is my part here. I'm going to stop my share again. Okay, over to you, Grasvidas.
Yes, thank you, Jonathan. So thank you guys for the opportunity to be in this live stream. And today I would like to present our tool, JoinerCAD. So first of all, I would like to share my screen. I hope that you can see it. And so the first things first. So what is JoinerCAD and what it does? JoinerCAD exists because Fusion is a great design, universal design tool. But when it comes to woodworking area, there are some very specific needs, and Fusion does not cover it. So furniture design today is moving really fast, as Nick already said. So designs are more complex, never straightforward, and customers don't want to wait months until the idea will be finished to product. And the mix of materials is getting more and more diverse. So that's where JoinerCAD comes in. We build it to speed up everyday work. So skeleton design tools allow to model more quickly. Real woodworking materials you can manage and assign for the models. Hardware elements places itself automatically, provides the whole information. And bill of materials are always accurate. You don't need to fill the Excel sheets manually. JoinerCAD can do it for you. Many more features are not mentioned, but those are crucial as well and built in our product. So JoinerCAD just cuts repetitive stuff, so designers can focus on creativity and go to manufacturing faster. We have been building CAD tools for specifically for furniture companies over 15 years. So when Fusion came up, it was a natural step for us. They thought, okay, we already have our own know-how from other products like Woodwork for Inventor. So we need to adapt these tools for Fusion, and that's how JoinerCAD started. So as I said before, JoinerCAD is a set of tools, but today I would like to present 4 of them for the most useful tools, I believe, for the designers, which can speed up your design process more quickly. So I have a bedside table like this, and I will show parts of it and how to design it using JoinerCAD, and how the process would go if you will use JoinerCAD in your design. So first thing, just create a simple box which will be used like a skeleton body. I can create a simple sketch. It's turned on. Okay, like this. And let's start from the center. Let's add some dimensions. Project some edges. I will not design the entire furniture, it's just parts of it, so you will not see the entire process. Okay, let's make an extrusion. 365, and it will be a new solid, new body. And this body will be used like a skeleton, like a frame for our design. We are not restricting the ways how you design your furniture. You can use bottom-up or top-down methods as skeleton as well. But we believe that skeleton design method is the most powerful tool for furniture makers, and it allows you to control your design as necessary, using parameters and implement changes if needed. So what I'm doing right now, I'm just presenting this body like a skeleton body, and removing faces which should not be covered by panels. And I will leave all the settings like that right now. But as you can see, you can rename, change thicknesses, direction, how the panels are created, and so on. So what we have right here, we have a body which is covered by panels, and these panels are real components which can be covered by film materials, cover materials, and so on. So let's quickly remove the visibility of a skeleton body and make a trim operation. Trim these two side panels by these two panels. As you can see, all corners are cut, and panels are now intersecting each other. Let's do the same for the backside. This one and all surrounding panels will be like rounding panels. So as you can see, the back panel is also cut. So just a simple method how you can create boxes or any other shapes if needed, because right now designers can, I don't know, adapt to the attics, the furniture for the attics or for the niches or something like that, and it's not always the rectangular box. So let's create another body, another skeleton on this panel, and I will remove the visibility of this. Simple sketch. I take 20 millimeters from this side. Okay, I need to project this edge as well. Let's project this one. 20 millimeters, like so. This, let it be 200 millimeters, and the back should go like this. Let's extrude it by 150 millimeters, and again it will be a new body. So I have another skeleton. As you understand, I can create as many skeleton bodies as I need, and I will also create a simple box like this. But this time, let's reduce the thickness to 16 millimeters. This time I would like to use trim meter command, and I will cut corners in 45 degrees. Sorry, not this one, but this one. When meter is done, we can use the same trim and cut bottom part like so. So as you can see, we have simple box with meters, and the bigger box which has trims, which make these panels perpendicular to each other and no intersection between them. So my first part the presentation of the skeleton design is done. Let's move to the another side. Let's move to the another step, and let's assign materials. Why we need to assign materials? Because when we are assigning materials, we defining how these parts will be measured in a specification, in a bill of materials. Let's say if we are using solid wood, it will be calculated in cubic meters. If we are using board, it will be a square meters. If it will be a rod, it will be just meters, linear meters, and so on. So it depends on the type of the material which has been assigned to the component. For this operation, for the material assignment, I'm using material assign tool and select each panels which I would like to cover in solid type material. Click OK. JoinerCAD assigns attributes for the specific components, and in that way we are calculating necessary parameters, how big or how small the work pieces are, and how I should add or how I should subtract from the final component dimensions in a specification. So let's remove visibility of this one, and I have my box right here. And for this one, I would like to assign board type material. It will be HDF. And let's paint it. Paint is one of the cover materials. We also have veneers, we have edge bands, we have multi-layer covers, and vacuum films. And what I would like to say that when we are applying cover material, we can say how it will be calculated. It will be synced, or it will be added on top. Depending on this, the final dimensions of the part will be increased or stays the same like you model it. Also, we can define how faces will be selected. It will be single face. We can select all tangent faces, which are connected tangentially, or it will be the entire part. Because I'm using paint in my situation, I would like to cover the entire part. Let's turn on visibility of this one. So, as you can see, we have a carcass and a small box inside of it. We also have grain direction control tools. So if you want, you can adjust the grain direction. As you can see right now, grain direction of this component is horizontal. Let's make it vertical by changing grain direction up to 90 degrees. And the texture was rotated, and part corresponds to my wishes. So this was the second step in a design process. First of all, you need to create a solid geometry. Now I'm assigning materials, and the second step will be, the third step will be hardware placement. So this is the same model, and okay, let's add some hardware. I will remove visibility for this box, and I'm calling hardware attachment command and looking for the smart hardware components. With installation, we provide two types of hardware. First one is a simple hardware. There are some legs, handles, screws, etc., which do not have any logic implemented right now. And additionally, we provide smart hardware. Smart hardware components allows you to place them in your design. This hardware components adapts to the situation, calculates necessary quantities if needed, and so on. So we are using fixed connection. Let's say it will be minifix. And right now I should define which components should be connected by this minifix connection. I'm selecting all these three components, and right now I'm defining the direction of the cam orientation. It will be in this side. Together with the hardware, I mean with the minifix components, also dowels are presented, and moreover, all hardware components come with hole information. This means after, when the hardware components are placed, we can cut holes automatically according to the specification, how we need to build them. So as you can see, 4 minifixes are placed. Let's do the same for the other side. Same 3 ports, this direction. Let's click OK. Okay. We have 4 additional minifix connections right here as well. So I will turn on visibility of the box, and let's quickly turn off visibility for the characters. What I would like to do is I would like to add additional components. Fixed connection, lamella biscuit, edge type. Edge means that you are connecting 2 boards using edges. And right now, because I don't need to define the direction, how the component will be orientated, I'm just selecting all these components, and after click OK. All of them should be, all 4 lamellas should be added. Sometimes it may take longer than you expect. At least you don't need to do that manually. Okay, so all 4 components all 4 lamellas are inserted, and now let's do the magic. Let's cut the holes. And for this, I'm using sculpt command. Automatically collect all the necessary components. After click OK. It should subtract holes from the panels. Okay, let's say I would like to isolate this right side panel. And as you can see, minifix cam holes are right here, dowel holes are right here, and so on. So it looks like we are good to go. Let's check the box. There is our front panel and lamella slots are created. So in this case, all the necessary information was added, holes were cut, and we are good to go to create our drawings using standard Fusion tools. Final part, which should be covered, is bill of materials. And for that, I would like to open this final design. And right now, what I'm doing, I'm calling bomb command. Okay, let's reduce the size of the window. And as you can see, we have all information from the model. So we have a structure of each individual subassembly. So we can select each individual part, let's say box front, which was created right here. And we have final dimensions. If we will expand this component, we will see what size of the workpiece will be, how many square meters will be used for the front panel, and so on and so on. Also, here are 3 other types, standard tabs, parts only, where you will find all information about parts, or material summary, information about materials. You can add additional tabs for your own specific needs. Usually I'm using additional tab for purchased components to filter them out from the entire assembly. And when we are happy with the final result, we can export it to the home report. The JoinerCAD installation, we provide several Excel templates, so you are free to use them. You can change them according to your needs. Let's export the final result, open it. And right here I have bill of materials. The design is presented in a different ways. So product structure, so you can see structured list, complete parts list, parts only. In other words, cutting parts list. This would be useful for then you are ordering components for the outside of your company. Material summary announce you how much material you need. Structured material summary, material sum by products, and etc., etc. So as you can see, the necessary information for the production is ready, and you can make your own order. So that's it from my side for today.
Wonderful. Great stuff. Gracias. Thank you very much. Let me quickly, for some closing slides, share my screen. Go. Okay, good stuff. So just to round us up for today, we have heard from the beginning that the furniture industry is actually an industry that is rapidly changing at the moment. And Fusion, with its multiple workspaces, can solve the end-to-end, or can be the end-to-end solution for that particular industry. However, as Jonathan also has mentioned, there are still some gaps that we have not solved in Fusion yet. And this is where actually JoinerCAD comes in and can solve some real world woodworking challenges. Before we're going to go into the Q&A section, as always, there's a couple of call to actions from our side. With Fusion, you can learn, you can try it, you can talk about it, and most importantly, of course, you can buy it. But before you buy, please try Fusion first. And on this QR code, you can also start directly a 30-day trial with Fusion. But more importantly, there is also a special promo right now running in cooperation with JoinerCAD. If you're using the discount code JCADWOOD, you get 40% off of JoinerCAD, and this promo is going to run until the 31st of December 2025. Also, if you're scanning this QR code on the very left side, you can directly download also JoinerCAD. With that said, we're gonna go into the Q&A section. And I've already seen there's a couple of really good questions. Let me quickly stop sharing my screen. If we can get our speakers on the panel, wonderful, great stuff. I would ask you to please unmute yourself. And the first question, Rashidas, that's directly for you. Could you talk a little bit more about if there is some CAM capabilities also coming into JoinerCAD in the near-term future? Is there anything that you guys are developing right now?
Actually, yes. We are in a developing mode right now, because at the moment JoinerCAD provides information about parts, materials, etc. to the BOM reports. But many users are using Fusion CAM, and this CAM should be connected with JoinerCAD components. For that, we need to calculate how to reduce the size of a component, or maybe how we should increase the component, and so on. So many work in the background is right now.
Yeah. Really good. And I got immediately also a couple of more questions for you. Hope you're ready. So the next one is, can you talk a little bit about like the implementation of JoinerCAD, also in the everyday lives of companies, but also about the learning curve?
I wish to believe that. So the JoinerCAD is pretty easy to understand, and a couple of videos on YouTube, and you are good to go. And I would like to say that JoinerCAD has pretty flat learning curve, from my perspective at least, and I hope that's for others as well. So the software is more plug and play. It's not a solution, a big solution for the big companies and so on. So I believe that users who are using Fusion are familiar with commands and so on. So,
yeah. Okay, really good. The next question, so we talked already about the promo that we are running right now together with the 40% off. Somebody asked in the chat beforehand, is JoinerCAD a free add-on or is it a paid on? Can you talk a little bit more about your business model and your paying options behind?
We have two license types. The first is Pro version, which unlocks all possibilities in JoinerCAD. And of course, we have a free version, which is lifetime free version. And you can use JoinerCAD with reduced functionality. Additionally, I need to say that we are using subscription model, so pay as you go.
Okay, really good. Can you also talk a little bit about like the differences between the free version and also then the paid version? What can the audience expect if they are paying for JoinerCAD?
Free version provides functionality which is the basic functionality which is necessary to create your own documentation for the simple projects. If you need more advanced features like, I don't know, hole cutting, holes, sculpt command, or you need more advanced materials and so on. So that is covered by Pro version. Okay,
really good. So with that said, we have two more questions, both also for you, Gracidas. Hope you're ready. The first one is, can we use custom hardware libraries?
Yes, you can. We are providing instructions how to create your own components. So you can select your own supplier, add additional attributes to the components, and use if needed.
So. Okay, good. Great stuff. And then the very last question for today is, can this be used for metal frameworks as well?
Yes and no, I believe. It's a good question. We are more focused in woodworks for the wood, and yeah. So you can use rods. Let's say if you are calculating rods in your specification, okay, you can use it, but we are not working with sheet metal, let's say, or structural shapes like Inventor does.
Okay, really good. With that said, this is the end of all the questions that we got already for today. I gotta give a big thank you to you, Gracidas, and also to you, Jonathan, for showcasing both Fusion and JoinerCAD today. It was a pleasure to be here at this YouTube Live with you. And with that said, I wish everybody a beautiful day. Talk soon.
Thank you very much.
Thanks. This was great.